Okay, for our next section, 11.3, we're going to be introducing a new type of function. It's called logarithmic functions. But before we can talk about what a logarithmic function is, we just need to review what we're going to need for logarithmic functions, and that's, of course, exponential form. As we can see here, what I have given you are some examples. Exponential form, we have a base number. I'm going to use the letter B. I'll let P represent the power, and N, of course, is the number that it's going to equal. So let me just write that. B is a base number. P will be the power that we're going to raise the base number to, and N is the number that it's going to equal when you take the base and you raise it to the power. And let's just take a look at these examples. And so for the first one, we have base 2 raised to a power of 5 equals the number 32. We have base 3 raised to the power of negative 2, and that equals the number 1/9. Over here we have base 9 raised to a power of 1/2, and that will equal, of course, the number 3. And then finally, we have the base number 1/4 raised to a power of 3, and that equals the number 1/64. Now, in all of these examples, there are certain conditions that need to be true. The base number, okay, whether it be the 2, 3, 9, or 1/4, all of those base numbers must be greater than 0, okay? Any number greater than 0 except the base number cannot equal the number 1. So these conditions are being satisfied. Our base numbers are 2, 3, 9, and the fraction 1/4. And all of those bases are positive, and they are not the number 1. There's another condition that needs to be satisfied, and that is the value of n that it's going to equal. The number that it's going to equal must also be a positive number, and we can see that is also true. We have the 32, the 1/9, the 3, and the 1/64. So these conditions are being satisfied. The power we don't care about. Okay, the power that we are raising our base number to could be positive or it can be negative. All right, doesn't make a difference. What does matter is the base, once again, must be a positive number. Excuse me. Must be a positive number, any positive number except the number 1, as well as the number that it equals must also be a positive number. And if these conditions are being satisfied in the exponential form, that's going to lead us into a different type of form. And that alternative form is called logarithmic form. Now, logarithmic form, I am going to use the same letters of B, P, and N, but I'm just going to rearrange their order. And let's see what the logarithmic form actually calculates for us. When we have things in exponential form, we are calculating the number that you get when you raise the base to a particular power. Logarithmic form looks something like this. We write the word log, then there's a subscript number b of n, and it's going to equal p. So logarithmic form, log base b of the number n, is going to equal p. So what does logarithms calculate? Logarithms figure out the power that you would have to raise a base to in order to get a particular number. So for example, let's take a look at the very first problem that we had, the example of 2 to the 5th equaling 32. If I was to write that in logarithmic form, I would write log base 2 of 32, and that would equal the power 5. Because once again, what is a logarithm figuring out? What power would I have to raise 2 to in order to get the number 32? Let's take a look at the second example that we did. 3 to the negative 2 power equals 1/9. If we were to write that in logarithmic form, we would write log base 3 of 1/9 equals a -2, because we want to figure out what power would I have to raise 3 to get the number 1/9, and that's what logarithms figure out, the power. That third example of 9 to the 1/2 power equaling 3, well, if we were to write that in logarithmic form, we would write log base 9 of 3 would have to equal 1/2. Once again, what power would I have to raise 9 to in order to get the number 3? And for this fourth and final example, if we were to write log base 1/4 of 1/64, the answer would be 3. And these conditions that I mentioned earlier must still hold true, in that the base must be a positive number, any positive number except the number 1. And the number that you are taking the log of, n, must also be a positive number, as we can see is being held true. Log base 2, log base 3, log base 9, and log base 1/4. All of those bases are positive numbers and not the number 1. You are taking the log of also positive numbers because n must also be greater than 0. So you have the log of 32, log of 1/9, log of 3, log of 1/64. Those are all positive numbers, okay? The p-value, once again, the power can be positive or it can be negative. There are no conditions on the power that it in fact equals here. So that's what logarithms do. Once again, logarithms figure out the power, okay? Now you want to feel comfortable converting back and forth from exponential form to logarithmic form. For example, if I was to write the log base 2 of 8 equaling 3, that's logarithmic form. We want to write that, of course, in exponential form. And exponential form, we would say that 2 to the 3rd power would have to equal the number 8. You're using the same 3 numbers, but you are just rearranging the order, okay? If, for example, we were to have the log base 64 of the number 8 equals 1/2, that logarithmic form can be converted to exponential form, whereby we would write 64 to the 1/2 power would have to also equal 8, okay? So you want to be able to, once again, convert back and forth from logarithmic to exponential, as well as exponential to logarithmic. For example, if I was to have 10 squared equaling 100, that is exponential form. We want to be able to write that in logarithmic form, in which case we would write that the log base 10 of 100 would equal 2. And I want to take a moment and look at this particular logarithm. Log base 10. Now, log base 10 is often known as the common log. And that's because of the base. Because you are dealing with base 10 is considered the common base. Okay, and since base 10 is the common base, when you're dealing with log base 10, you are now dealing with the most common log. And you'll actually notice on your scientific calculators, most of them have a log key. And if you were to type in log 100, okay, you would get the correct answer of 2, because your calculator is already pre-programmed for log base 10. So you might want to try that on your scientific calculator. You'll notice the log key Okay, if you type in log 100 and then hit the enter or the equal sign, your calculator will give you the correct answer of 2. Because once again, 10 squared is 100. Notice we don't have to write the 10, okay, it's understood. Why is it understood? Because 10 is the most common base. You could not use your log key for any of these other problems because they are not base 10. For the first problem, we had log base 2. For the second one, we had log base 3. You could not use your scientific calculator to figure out the log of 32 or the log of 1/9 because you are not dealing with base 10. You're dealing with all different kinds of bases. Okay? So if you do happen to have a problem involving log base 10, for example, if we had log base 10 of 1/1000, you could actually use your scientific calculator to figure out what this is. Because if you activate the log key, then you type in that 1/1000, your calculator should tell you the correct answer of -3. Why? Because 10 to the -3rd power is 1/1000. And that's what the calculator is figuring out. Once again, what power would you have to raise your base to in order to get that particular number? Okay, so that's what logarithms do. Now, also in section 11.3, we need to take a look at solving logarithmic equations. We have seen how to solve all different types of equations. We started out, you may recall, the semester with solving linear equations. Then we talked about absolute value equations. Then we talked about solving quadratic equations and rational equations and radical equations. And in the last section, 11.2, we talked about solving exponential equations. Well, now here in section 11.3, we have to take a look at how to solve logarithmic equations. For example, let's say we had log base, let's say 5 of x equals 3. Here's an example of a logarithmic equation where we want to solve for the variable x. Well, what we want to do here is we want to convert this into exponential form. So we're going to rewrite this as 5 to the 3rd power equals x. And now this becomes relatively easy because 5 to the 3rd power is simply 125. And that would be your solution for x. Okay, that one wasn't too bad. Let's try one that's a little bit more complicated. Let's say we had the log base 3 of 7x plus 18 equals the number 4. Once again, here we have a logarithmic equation. We want to solve for the variable x that's located here. So once again, what we will need to do is we want to convert this to exponential form. When we write this in exponential form, we would want to say that 3 to the 4th power would have to equal the 7x plus 18. Well, before we could do anything to solve for the variable x, we first have to figure out what is 3 to the 4th power. Well, 3 to the 4th power, that's 81, equals 7x plus 18. Now we have a simple linear equation that we want to solve for the variable x. So we can do that. I would subtract 18 from both sides. That would now give us a 7x equals 63. And of course, now when we divide both sides by 7, that would give us our solution that x would have to equal the number 9. So 9 would be the solution to that particular equation. What if x was in a different location? Let's say, for example, we had the log base x of the number 36 equals 2. Now we're figuring out the base. Okay, well now, once again, what we need to do is rewrite this in exponential form. So we would have to write x squared equals 36. I take the base x, I raise it to the power of 2, and that equals, of course, the number 36. Well, now we have to solve this for x. Well, here we have a quadratic equation. Well, we can very simply go and take the square root of both sides. And in doing so, we would get x equals plus or minus the number 6. However, there is only one solution here, because recall our conditions earlier that we talked about when we referred to about logarithmic form. We said that the base number had to be a positive number, any positive number except the number 1. And so that's why here, in this particular equation, as we solve for the base x, x will only equal the positive 6, because we cannot have a negative base as a possible solution. Let's try another one, a little bit more involved. Let's say we have the log base maybe x plus 5 of the number 64 equals 3. So now we have log. Our base is a little bit more complicated, not just the variable x, but the algebraic expression of x plus 5 of the number 64 equals 3. Well, now once again, we have to go and we want to write this in exponential form. That would give us an x plus 5 to the third power equals 64. Okay. Well, we have to get rid of this cubed power. Okay. When we wanted to get rid of the squared power, we took the square root of both sides. So if we want to get rid of a cubed power, we're going to have to go and take the cube root of both sides of our equation. When we go and take the cube root of x plus 5 cubed, we get just x plus 5, equaling, if we take the cube root of 64, that of course would give us 4. And so now, what we need to do to solve for x, let's minus 5 from both sides. That would give us the solution that x equals a negative 1. And that would be the solution to that particular equation. Let's try a slightly different one. Let's say, for example, we had log base 2 of 16 equals x. Well, we need to come up with the exact value of x here. What might this number be? Okay. We can't actually use our calculator for this because our calculators are pre-programmed for log base 10. So, like we've been doing, let's go and rewrite this in exponential form. So now we would have 2 to the x power equals 16. And now what did we create? Here we created an exponential equation. Now remember, how to solve an exponential equation is that property of equality. We need to have the same base on either side of the equation that we talked about in section 11.2. And if we are dealing with base 2 on the left side, I need base 2 on the right side. So I'm going to keep 2 to the x on the left, and instead of the number 16, I'm going to think of this as 2 to the 4th power. And now because we have equal bases, that means our exponents will also be equal, in which case we would be able to say that x equals the number 4. Let's throw you a really complicated one. For example, let's say we have log base 36 of the 4th root of 6 equals x. Okay. For this last example here, this one's a bit more complicated in that once again we have to rewrite this in exponential form. And in doing so, we would have 36 to the x power would have to equal the fourth root of the number 6. Okay, so once again we have an exponential equation. Now remember, in order for us to solve these exponential equations, we need to have the same base. Well, on the left side, I have 36. I might want to think of that as a base 6 number. So I'm going to write that as 6 squared to the x power. And instead of the fourth root of 6 to the first power, let us not forget that we can change radicals into fractional exponents, in which case that would give us 6 to the 1/4 power. Okay? And so now we have a power raised to a power. That means we can multiply those powers. So I would have now 2x is going to in fact equal the exponent on the right side of 1/4. And so now to solve this for x, you would have to multiply both sides by 1/2, in which case we get our solution of x equaling 1/8. Okay? So that's pretty much what logarithms are all about. Okay? It's an alternative form to exponential form. Okay? Once again, you need to feel comfortable and confident in converting from one form to the next. Pretty much it's just a reorganization of those same three numbers. And then we talked about solving logarithmic equations. In general, you take any logarithmic equation and we look to convert it over into exponential form. Once it's in the more familiar exponential form, you'll be able to solve those particular equations. Okay? That completes section 11.3. Be well.